Hey guys, welcome to the MCAT 2017 day 1 paper. So the way this video is going to work is like I usually set up all the questions at the beginning. So pause the video at the start of each question, have a go by yourself, see how far you get with the question, and then just see how I go about getting the answers. And for some of the questions you can get merits or merits are achieved just by writing a few things. So just keep an eye out for that as well. Okay, so let's get started. Okay, so we've got question 1 right now. So in question 1, what you've been asked to find is D, and you've been given U and T as 3 and 5. So the first step I always do is write the equation as is. So UT plus 3T squared. And then in the next line I'm substituting U, which is going to be 3. It's multiplied by T, which is 5, plus 3 times 5 squared. So what I've got is 15 plus 3 times 25. So it's 15 plus 75, and my answer is 90. So basically this question is worth and achieved, and you have to get 90 as the answer to actually get an achieved for this question. Okay, second question, we have got a quadratic. So what we need to do is we need to actually factorize the quadratic first and then try and solve it. So the way I go about it is I take out 2 times negative 9, which equals to negative 18. So basically I'm looking for two numbers that multiply to negative 18 and also adds up to negative 3. So in this case, my two numbers are going to be negative 6 and positive 3. Because negative 6 times positive 3 is 18. Negative 6 plus 3 equals to negative 3. So what I'm going to do is I'm going to split the negative 3x. So I'm going to write down as is for 2x squared. But negative 3x is going to look like this now. It's going to be negative 6x plus 3x. And of course we have a minus 9 at the end, and that's equal to 0. So I do factorization, but I split them up into two parts. So on the left hand side of the light blue dotted lines, I look at between 2x squared and negative 6x, what's the common factors? I have 2x, so that would become x minus 3. And then on the right hand side of the blue lines, I can see 3 is a common factor, and that's going to have x minus 3 equals to 0. Now in this statement, you can see that x minus 3 is the common factor for both of these terms. So I'm actually going to take it out, and I'm going to write it as x minus 3 multiplied, and I just got to check what's left over, and that's the 2x and 3. So I've got 2x plus 3, and all of this is equal to 0. So getting up to here will get you an achieved for this particular paper, but then for getting a merit you need to actually solve the question. So that means you've actually got x minus 3 equals to 0, or 2x plus 3 equals to 0. So rearranging, you've got x equals to positive 3, and in the second situation you've got 2x equals minus 3, and then x is equal to negative 3 divided by 2. So those are your two answers, and if you just write it down at the bottom, that x is equal to 3 or negative 3 over 2. So solving it up to here will get you a grade of merit. Now let's say you actually make a mistake here and you don't factorize it correctly, but you kind of got an incorrect factorization, but then you carry on doing this, you could still get an achieved for it. Okay, let's go to the next question. Alright, so this question here, it's kind of like I think it's like 3 parts to it almost. First off, you've got a set of simultaneous equations that you've got to actually solve. Then you got to figure out what x and y is, and then you got to actually do x minus y. So you got a lot of things to actually do for this question. So how are we going to go about doing this question here? As I said, there's multiple ways of doing this. So the one I'm going to be choosing is substitution. So I'm going to take the first equation here, which is 6x minus y equals to 21. I'm going to rearrange so that y is by itself. So if I was to do that, what I would end up with is 21 negative y. When I switch this over to the other side, it's plus y. And then bringing the 21 to the side, to the left-hand side, I'm going to get 6x minus 21 equals to positive y. So what I can say is, therefore, y is equal to 6x minus 21. Okay, so that's the first step. The second step is I'm going to take y. And I'm actually going to substitute it right there. Okay, so what I'm going to end up with is, so if I have negative x plus 6y is equal to 14, and because y is equal to 6x minus 21, I'm going to replace that right there. So what I'll end up with is negative x plus 6 multiplied by 6x minus 21, and that's actually equal to 14. So expanding this out, I get negative x plus 36x minus 21 times 21 times 6 is 126, and that's equal to 14. So 36x and minus x will become 35x. 35x minus 126 equals 14. So rearranging this, I'm going to get 35x equals 14 plus 126. So what I have is 35x is actually equal to 140, which means x is equal to 140 divided by 35. So at this point, I know 35 times 2 is 70, 70 times 2 is 140, so I can actually say that x is equal to 4. Okay, so once you have x equals to 4, you actually need to figure out what y is. All right, and we have what the equation for what y is. Y is 6x minus 21. So that means we can write that here as 6 times x, but because x is equal to 4, we're going to end up with y looking like this, which means y is equal to 24 minus 21, which is equal to 3. So now we've got x and y, so then we can actually do what x minus y is. So if x minus y would be 4 minus 3, which equals to 1. Okay, so in terms of grades, lots and lots of possibilities here. I think you need the final one for an excellence grade. For a merit, it's a solving for one variable. So if you get an x or a y, you could end up with a merit. And then for achieve, there's a lot of combination of things that you can do, guys. So like I think even rearranging one, yeah, it's like 6 bullet points in the answer schedule. I don't think I'm going to go through each one of them. But yeah, so basically that's what you need to do for this particular question. All right, let's have a look at the next one. All right, so we've got a index question here. So what's important to notice with this particular question is that it would really help to kind of start writing everything in powers of 3. Because we have a power of 3 right there, it would help to actually convert everything to power of 3. So what I mean by that is converting 9 and then possibly 87. Okay, so let's write down what we can actually do. Now 9, we know that 3 squared is actually equal to 9. Okay, so that means I'm going to replace 9 with 3 squared, and that's multiplied by 3 to the power of x minus 4, and that's greater than 87. So far so good. So the next part is, because 3 is the same base, I can actually add the two powers. So I'm going to end up with 3 to the power of x minus 4 plus 2 is greater than 87. And so simplifying this, I get 3 to the power of x minus 2 is greater than 87. Okay, now this is where we get up to so far, because 87 can't, like without a calculator, you can't actually write 87 as 3 to the power of something. Because watch what happens. When I write 3 to the power of 3, that's going to be 27, because 9 times 3 is 27. 3 to the power of 4 is 81, because 27 times 3 is 81. And then 3 to the power of 5 is actually 243. Now, you can't just go 87 is equal to 3 to the power of 4 point something. It doesn't actually work like this. So, and I guess that's where this symbol really matters. All right, so you're looking for what value of x is going to be that you can put in there so that this left hand side will be always bigger than 87. So if you look at it, all right, if we have this green number equal to 3 to the power of 4, it's actually going to be false. All right, because if you think about it, if I say, what I mean by is if 3 to the power of 4 is in the green box, then I'd end up with something like this: 81 is greater than 87. But that's actually not true, so it's actually false. So I guess I need a different number, and I guess the next number that I have is what's in the orange box. So if I put the orange box in here, that means I'm going to get 243 is greater than 87. Now, is that true? Yes, that is true, which means I can actually say 3 to the power of x minus 2 should equal 3 to the power of 5. Okay, so that means because they're the same basis, I can actually say x minus 2 is equal to 5. And then rearranging it, I'm going to get x is equal to 7. All right, but here's some of the important things you need to understand. All right, the first point is this: x has to be a whole number. It can't be like a decimal point or anything like that. The second thing is, I'm going to go back to, is the sign here. All right, because x can't just be 7. Like, let me just show you what I mean by, like, if I put 3x is 7, if x equals to 7, right, I'm going to get 3 to the power of 7 minus 2, which is equal to 3 to the power of 5, and that's equal to 243. So yes, it's true, but x could also be 8, okay, because you could get x 3 to the power of 8 minus 2, which is 3 to the power of 6, which is going to be a number that's actually bigger than 243. Now, I mean, like, because I'm trying to do this without a calculator, I'm actually saying that this number is going to be bigger than 87. All right, if I go like this, if I keep on going, x equals 9, x equals 10, all these numbers are actually going to be bigger than 87. So my final answer for what are all the values that x can be, x can actually be 7, 8, 9, and it can just keep going. So the easiest way to write this is I'd write it like this: x has to be greater than or equal to 7. That's one answer. Or you can also say x is greater than 6. Okay? Because if you think about it, answer being greater than 6, that's actually 7, 8, 9, and 10, and so forth. So, grades-wise, excellence for getting all the way down here. And I think you've got achieved could be putting it in one form like this. Guess and check giving. Okay, what else do we have? Consistently equating of indices. So that's one. That's one. And then I'm looking at another one. So you could do a guess and check as well. That could be an achieved. But I guess for merit, you actually need two achieves to actually get a merit. Okay. Cool. That's basically it for this little question, guys. We'll go to the next one. Okay, so here we have a question that is just a bit of wordplay here. So I guess I'm going to start following it from like each line. So in the first line, it says Jane thinks of a number, which is k. When Jane's number is cubed, so if it's cubed, that means Jane's number is k and it's cubed. The answer is m times k. Okay. Then the third line, it says when Jane's number is squared, so I've got Jane's number, which is k, and it's squared, it is n more than k plus 5. So k plus 5 would look like this. And if it's n more, it's going to be another n put together. Okay, so just writing this, like getting these two equations, just I think one of them, it's an or, so one of them gets you an achieved. Now, its final part of the question actually says, give an expression for n in terms of m only. So my first step is this. I know that if I want a expression for n in m, That means I got to get rid of k. So on this right hand side, I've actually got k cubed equals mk. So if I rearrange this, where m is by itself, I'm going to get k cubed divided by k equals m. Okay, because remember that when k goes to the, because k is being multiplied on the right hand side, when it moves to the left hand side, it becomes divide. Now k cubed over k is equal to k squared, and that's equal to m. Okay, so we've got k squared equals m. So what I'm going to do right now is I'm going to take the k squared and I'm going to substitute it here. Because I've already got k squared, that's equal to m. So I'm going to write down m is equal to k plus 5 plus n. Now here's the problem. I need an expression for n in terms of m only. And unfortunately, I've still got this k. I need to get rid of the k. So I got to go back to my original equation. I'm talking about right here. See how it's k squared equals m? Then I can actually say k would then be square root of m. And because k is equal to square root of m, now I can continue with my equation on the left hand side. I'm going to get m is equal to, and instead of k, I'm going to put that as square root of m plus 5 plus n. But remember, you're asked to figure out what n is. So I'm going to rearrange everything so that n is by itself. So I'm going to get n equals m, and square root of n, when it comes to this side, it becomes minus square root of m. 5 when it comes to this side becomes minus 5. So in the end, I have my expression for n, which equals m minus square root of m minus 5. And getting it to that last point there gets you an excellence. For achieved, these are some of the things you can get for achieved. That's achieved. I already pointed out one there. Consistent equation, expression for n in terms of, okay. So let's say you do something wrong and you kind of show you're working, you could also get achieved for that. And for merit, you actually need 3 of these achieved things to get a merit. Okay, that's basically it for this little question, guys. We go to the next question. Right, so question 2, we have give the equation for x in terms of h. So it's a rearranging question. So we've got h is equal to 9 minus 4x squared. So we've got to start rearranging it. The first thing I need to get rid of is the 9. And when the 9 shifts over to the other side, we have negative 9 plus h equals negative 4x squared. Okay, the next part is we want to get rid of the negative 4. So we would have x squared. I'm just going to rewrite this as h minus 9. And that's divided by negative 4. So at this point you have 4x squared, and so you need it for x. So x would then equal square root of h minus 9 divided by negative 4. All right, and remember that anytime you take a square root of a number, you actually end up getting plus or minus as well. So in this case, we're going to put plus or minus. And also one tiny bit, we don't like negatives in the denominator. So because we don't like negatives in the denominator, we're going to rearrange it so it'll look like this. Negative h plus 9 divided by 4. Alright guys, basically that gets you an achieved. Okay, let's go to the next question. So question 2, you've got a nice simplified question here with 2 quadratics, one in the numerator and the denominator. Now here's one of the things. I don't know why, but it's like every time people see this question, I always see people do this. They take out x squared like this. They take out the x and x like this, and they start doing funny things with this. All right. So just remember, guys, that's actually the incorrect way of doing things. The first thing you really want to be doing is that whenever you see a quadratic and with on top of another quadratic is you factorize. Okay. So what we're going to do is we're going to factorize the numerator. We're looking for 2 numbers that multiply to positive 4 and add up to minus 5. So that's a nice simple one. We've got negative 1 and negative 4. Okay. And in the denominator, we have 5x squared minus 20x. Now, I'm going to give you guys a big hint here. I think it's every time you actually do one of these questions, whether it's in level 1 or level 2, the whole point of simplification is that you're going to cancel one of these brackets out. That means in your denominator, you're going to get an x minus 1 or an x minus 4. It's just That's just the way the questions are set up. Okay, so always remember that if you ever get stuck with these types of questions and don't know how to factorize the bottom. But anyway, in this case, what we have is a common factor of 5 for both of these terms. So if I take 5x squared and I take 5 out, actually no, I've got 5 and x as a common denominator, so I can actually take 5x out, and what I'll end up with is x minus 4. So at this point, you can actually see easily that x minus 4 is the common factors in the numerator and the denominator, and what you end up with is x minus 1 divided by 5x. Alright, and guys, I'm not going to lie when I say this, but this is possibly one of the most easiest merits you can actually get in this paper. For achieved, you either need to factorize the numerator or the denominator once, but yeah, I think this is a really easy merit to actually pick up. Okay, let's go to the next question. Alright, so we've got an L-shaped model. Alright, and in this question it's asked to find us what's the perimeter of the model in terms of x. Okay, now I'm going to try and show you guys this in two different ways, alright? Just because for the perimeter, it just works really nicely with the second method that I'm going to show you. So the first method is actually looking at each of the sides and trying to figure out what they are. So we know that this part and this part here is actually adds up to the bottom part, alright? So I'm going to actually write that as 2 plus 4x minus 2. So, which means when it simplifies, it actually ends up being 4x. Okay, that's the first thing. The second thing is this. I know that this part here, 12x plus 1 minus 2x plus 3, is actually going to give me this remaining green part. So I'm going to write that down here. So I'm going to get 12x plus 1 minus, make sure I put the 2x plus 3 in a bracket. I'm going to end up with 12x plus 1 minus 2x minus 3. That actually simplifies to 10x minus 2. So with saying that, I've actually got 1, 2, 3, 4, 5, 6 sides there. So let me just show you guys that again. So I've got 1, 2, 3, 4, 5, and 6 sides. So the perimeter is just going to be adding up all of those things together. So 1 is 2 plus 12x plus 1, which is the second side, plus 4x, which is the third side, plus 2x plus 3, which is the fourth side, plus 4x minus 2, which is the fifth side, and then the sixth side is 10x minus 2. So combining all my x's together, I've got, what do I have? I've got 12, no, I'm going to write that in a different color. I've got 12, 16, 18, 22, 32x. Then I combine all the numbers together. So I've got 2, 3, 6, 4, 2. So that ends up being my perimeter. Okay, 32x plus 2. Now I want to show you guys a really a different way of actually doing this. The different way of doing this is actually doing, I need to actually draw this up again, sorry. So we've got 2 here, we've got 12x plus 1, we've got 4x minus 2, and then we've got 2x plus 3. So here's the thing, when you are working with L shapes, all right, what I can actually do is, I'm going to try and do this in a different way, but like, just have a look at this. So basically, this distance from here to here, this purple distance, is going to be the same as from there to there. All right, so that means that's going to be 4x minus 2. And then you got the green part here, which is from here to here, which is 12x plus 1. We know that this green part and this green part actually adds up to 12x plus 1. So I could actually do this. I could replace the whole thing there with 12x plus 1. And what you should end up looking at is a rectangle where this is 12x plus 1, and in the top there, 4x minus 2 and 2 will make it 4x, which means the bottom is going to be 4x, which means that's going to be 12x plus 1. And if you actually add up these things now, so if you go 12x plus 1 times 2 plus 2 times 4x, actually get 24x plus 2 plus 8x which equals to 32x plus 2. So as you can see, same answer for both of them. Okay, and it doesn't matter which way you actually do it. Now this was one of these really weird questions last year because you actually got excellence for this question, regardless of which way you actually went about it. And I think for achieved and merit minor mistakes, you got what is it? There's some, yeah, there are some incorrect answers that have been given which can get you up to a merit. So yeah, it's just a really strange question from last year. But anyway, we keep carrying on. Go to the next part of this question. So the second part of the question is that they're actually asking you for the area. Now this one is a little bit more, how do I say it? We can't actually use that whole square format that we did last time. What we do need to do is we need to split this up into two rectangles. All right, so my first rectangle, which is this one here, and then my second rectangle is here. So what I have is my first rectangle plus the second rectangle is going to equal 92 centimeters squared. So the area for the first rectangle is base times height. Now base is 2, height is 12x plus 1. So I'm going to end up with 2 times 12x plus 1 plus my second rectangle has a base of 4x minus 2. Let me just put that in a different color. And a height of 2x plus 3. So my second rectangle is going to have 4x minus 2 multiplied by 2x plus 3. And all of this is actually equal to 92. So expanding the brackets out, I get 24x plus 2 plus 8x squared plus 12x minus 4x minus 6 is actually equal to 92. So simplifying this, I get 8x squared plus, what else do I have? 24 plus 12 is 36, minus 4 is 32x, and then negative 6 plus 2 is negative 4. And all of this is equal to 92. So simplifying this, I get 8x squared plus 32x minus 4 minus 92, and that's equal to 0. So I end up with 8x squared plus 32x minus 96 equals to 0. Now at this point you're thinking, oh man, this is like an ugly ass quadratic with 8 and 96. I don't have time to do this, to actually factorize this. Well, here's the thing. In these exams, you're not allowed to use calculators, which means the numbers that they give you generally are easy to actually work around. And what you should see is 32 can be divided by 8, and also 96 can be divided by 8 as well. So what you could end up doing is take 8 as a common factor, and you'd end up with x squared plus 4x minus 12 equals to 0. All right. So then what you can do is you can actually say, well, 8 goes to the other side. 0 divided by 8 is just 0. So you end up with just x squared plus 4x minus 12 equals to 0. So factorizing this, you end up with two numbers that multiply to positive 6 and add up to, two numbers that multiply to negative 12 and add up to positive 4. So we have plus 6 and minus 2. So therefore we can say x is equal to minus 6 or positive 2. Now the question is asking what is the value of x. So you need to say x can't be negative. Therefore x is equal to 2. So in terms of grades, excellence for the final part of getting answer equals to 2. Now for merit you need to get like 3 achieved skills. So I'm looking at the achieved skills is something like expanding, okay, consistently simplifies, that's 1, solving. So yeah, you need about 3 of these skills to get a merit, but then if you get the final answer you get an excellence. All right, let's go to the next question. All right, so for this particular question, what we have is we've got someone that's actually laying square concrete tiles. He's deciding to make a square pattern, all right? So if you look at it as a square pattern, so he could have a, I'm going to put down the pattern number here. So he could have a 1 by 1, 2 by 2, 3 by 3, 4 by 4, and so on. Okay, so now if we look at the number of tiles he needs, it'll be like 1, 4, 9, 16 and onwards. But because he changes his layout to make the length 6 tiles longer and the width of the deck 4 tiles shorter, that means, so if I look at pattern number 1, it's no longer going to be 1 times 1, but it's going to be, because it's one of the lengths is 6 tiles longer, it'll become 1 plus 6, which is 7, multiplied by the width of the deck is 4 tiles shorter, so 1 minus 4 is negative 3. Now you see how that doesn't actually make sense, because that means he's going to be using negative tiles. So what you're trying to figure out is, and if you were to keep on going like this, you would get 8 times negative 2, 9 times negative 1, 10 times 0, 11 times 1. Okay, so there we go. That's when we have our first real thing that's actually happening, the rectangular pattern that's actually happening. But when he finishes it, he's realized that he needs actually 2 extra tiles. And the question is, how many tiles did he have to start with? So let's have a look at, we're going to put this as x. All right, that means the number of tiles he has, actually wait, pattern, the original square pattern that he has would be x times x, right? Which means the number of tiles he has is actually x squared. Now the reason I wrote x times x is because that's length times width. And then when he finishes it, he finds out that he's actually too short. So if you look at the pattern for the rectangle, he is increasing x length by 6, so that'll become x plus 6, and then decreasing the width by 4, so that's going to be x minus 4. So let's go back out here and have a look at what this actually looks like. So the rectangular pattern is going to look like this: x plus 6 multiplied by x minus 4. And then, but the original square pattern that he had was just x squared. But when he finished the rectangular pattern, he found out that he needs 2 extra tiles to complete the rectangular pattern compared to his original one that he had. So that means I've got to add 2 to the original number of tiles he actually had. So that's how I actually set up the formula. Now once I've set it up, expand the quadratic, I got x squared minus 4x plus 6x minus 24 equals x squared plus 2. So simplifying this, I can see that x squareds actually disappear because they kind of on both sides. 6x minus 4x is 2x. So I've got 2x minus 24 equals 2. And then 2x is equal to 2 plus 24. Which means 2x is equal to 26. I'm going to carry on here. 2x equals 26. And then x is equal to 26 divided by 2. So what you end up having is x is equal to 13. So let's actually figure out what this means. So if he had 13, x squared is equal to 13 squared, which equals to 169. So number of tiles he started with is actually 169. Now let's go and have a look at what the pattern will happen. So if I substitute 13 into this pattern here, I will get 13 plus 6 multiplied by 13 minus 4, which is 19 times 9, which actually equals to 171. And as you can see, he is actually 2 tiles actually short. So excellence, if you get 169. Now achieved could, again, it's a multiple achieved question here. So if you set up this equation, you get an achieved. If you expand the bracket, you get achieved. Solving the equation gets you an achieved. What else? I think that's basically it. And then for merit, you need 2 of these skills. All right, guys, that's it for this little question. Let's have a go to the next part of this paper. So question 3 is, we've got area of a rectangle is basically this quadratic here. Let's take the length and width of this rectangle. So what we need to do is we need to actually factorize this quadratic. So I've got 3 times negative 40, which equals negative 120. So I'm looking for 2 numbers that multiply to negative 120. By the way, 3 times negative 40 is how I got this negative 120. And I'm looking for these 2 numbers also to be adding up to plus 2. So in this case, it's going to be, let's see, 10 and 12, is it? Yep, 10 and 12. So 12 times 10, 12 times 10, but the 10 is going to be negative. There we go, that makes it easy. So we've got 3x squared, and then the 2x, I'm now going to split it up as plus 12x minus 10x minus 40. Now comes, I need to factorize them by parts. So the first part I'm going to factorize here on the left hand side. I've got 3x as a common factor, which means I'm going to get x plus 4. And then on the right hand side, I've got negative 10 as a common factor. I'm going to get x plus 4. And then now, because x plus 4 and x plus 4 are common factors, I'm going to take out x plus 4, and I'm left with just 3x minus 10. So basically, I can write down area equals to this, or if you really want to get specific, is length is equal to x plus 4, width is equal to 3x minus 10. Now guys, it doesn't matter which way the length and width is, as long as you factorize, that's the most important part. Okay, so achieved for this part. Now the second part of the question, it says, given this quadratic represents the area of a rectangle, what would be the possible values of x? Now from the previous question, we actually ended up getting 3x minus 10 as one of its length, and then the width was x plus 4. We need to put each of these brackets equal to 0, okay? Because, or in other words, if you think about it, because it's asking what is the possible values of x, right? So if it's possible values of x, we can actually say minimum area for this rectangle is going to be 0. So we can actually figure out what the minimum lengths are. So that means 3x minus 10 is equal to 0, or x plus 4 is equal to 0. So if we put x plus 4, then we're going to get x is negative 4, while on this side we get 3x is equal to negative 10. And then x is equal to negative 10 divided by positive 3. Just realized my mistake, sorry. That should have been plus 10 there, plus 10 there. So x is actually equal to 10 over 3. So here's the thing though. It's asking you what would be the possible values of x. All right. Now the thing is, you can't have a measurement that's going to be negative 4. So x can't actually be negative 4, but x can be 10 over 3. But really, we have to say x has to be bigger than 10 over 3. Because if it's not bigger than 10 over 3, then your area is actually going to be 0. And so therefore, you don't really have possible, because you don't really have, if area is 0, that means either the length or the width is equal to 0. So just be aware of that. But just kind of say that x is greater than 10 over 3 in this case for it to actually work out. Okay. What's the other things for grades? You've got merit for this, and I think achieved is if you can get up to this part here for solving it, giving 2 solutions. Okay, let's go to the next question. Okay, so this question was a bit of a shocker when I actually saw this question in level 1 paper, but you know what? Considering the MCAT, you never know what's possible. So anyway, what are we going to do for this question? The very first step that I would actually recommend people to do is this. Because they both have a same base, because I'm going to write this question down first. 3x plus 4 is greater than 2 to the power of x squared. Because they have the same bases, we can actually get rid of the 2's, and we can rewrite this as 3x plus 4 is greater than x squared. Rearranging this, you actually end up writing 0 is greater than x squared, and then that'll become minus 3x minus 4. Okay, so in other words, I could actually rearrange and write this as x squared minus 3x minus 4 has to be less than 0. Or for what values is it less than 0? Now, if you guys have been watching my video series on the MCAT prep, you will know how to actually do this. And so I'm going to kind of go through it real quickly. First step, factorize. All right, you're looking for 2 numbers. Factorize. So you're looking for 2 numbers that multiply to negative 4 and add to negative 3. That's -4 and +1. All right, so we've got those two values right there. Now what I'm going to do is something slightly different here, just so you get the idea of how this actually works out. This graph, this equation right there is a parabola. Okay, it's a parabola, and we also figured out where the two roots are, and we figured it out right here, because we can write that x minus 4 is equal to 0, or x plus 1 is equal to 0, which means x is equal to +4 and x is equals to -1. So what does that mean in terms of the graph? So let's say we've got the x-axis right there. Okay, it is cutting the x-axis at -1 and +4, and we basically got to look at which zone the quadratic is under 0. So because it's less than 0, the zone that we're looking at is right there. So that means the solution for this particular question is when it's between -1 and 4, that's when this statement is actually true. So basically you just write it like this. Okay, the other way you could also write it is when you write up x is greater than -1 and when x is less than +4. That's the other way of writing it as well. So grades wise, all right, excellence for the final answer. Merit you could get somewhere here. Consistent solutions to an equation. Correct 1 point, so you could get 1 correct point, you get merit. For achieved, just doing that could get you an achieved. Relationship arranged, factorize. So factorize, you can get an achieved. Rearranging, you can get achieved. Yeah, so a wide variety of places where you can actually get grades from. All right, let's go to the next question. All right, guys, so we've got a classic simultaneous equations questions coming up right here. So got a couple of people raising money for a sports trip. Between them, they need to raise $1,000. There are only 5 weeks until they need the money. So what do we got? Tane gets paid 15 an hour. Pete gets 16 an hour. Blah, blah, blah. Between them, they work for a total of 13 hours a week. What's the average number of hours that each of them work per week if they are to have exactly the amount they need? Okay, so the first thing is we got to figure out how much money they need for each week. And that's actually right here. See, they got to raise $1,000 and they've got only 5 weeks to do it in. So that means each week they need to be looking at getting $200 on average. So that's the first thing we have to kind of work out. Second thing is coming up with the equations. Now Tane gets paid 15 an hour. So let's say T is number of hours Tane worked. And then we're going to go with P is number of hours. So Pete worked. So what we do know is that Tane is getting paid $15 an hour. So that's 15 multiplied by the number of hours Tane worked plus 16 for Pete, number of hours, whatever his rate, number of hours he worked. And that should actually equal on average a week 200. The other thing also that we know is that T and P, they work together for a total of 13 hours. So that means we can actually say T plus P is equal to 13. Okay, so this is our first step. We've got two sets of equations right here and we need to solve them simultaneously. So you can do this by substitution, elimination, whichever one actually works for you. All right, I'm actually going to choose substitution in this case because I've done elimination before. So I'm going to rearrange the first equation, second equation, and I'm going to rearrange it as P as actually equal to 13 minus T. Okay, so once I have that, I'm going to substitute into the first equation. Now my first equation is 15 times T. Let's get rid of that. Plus 16 times P, and that's actually equal to 200. So I've got 15T plus 16 times P, which is 13 minus T, equals to 200. So I've got 15T, expand the brackets, 16 times 13. That's going to be 208 minus 16t equals 200. So what I've got is 15t minus 16t is negative 1t. And then the 208 moves to the opposite side, which will become minus 208. And what I have is negative t equals negative 8, or I could just say t is equal to 8. Okay, so if t equals to 8, we know that p is equal to 13 minus t. So we got 13 minus 8, which equals to 5. So what's the average number of hours each of them work? So we can say Pete works 5 hours, and then Tane works 8 hours. And basically, guys, is that what we have? Let me just double check. No, that's what the question's asking. The question's asking for average number of hours, and so we've actually given it as 5 and 8 hours right there. So final answer, excellence consistently finds a number of hours. So if you make a mistake somewhere but you still get to a final answer, you could end up getting a merit. For achieved is one variable, repeat Tane work, number of hours. So this could actually end up getting an achieved. Tine worked, or identify equations, total amount per week in total. Yeah, so, or in one variable. So this is the other one. You can also get achieved. Sorry, not this one. Where did it go? Right there. That part there. Okay, that's basically it for this question. And we go to the last question, I hope. Alright guys, so for this particular question, there's actually two ways in which you can do this. I'm actually going to show you the long-winded way, which is, I mean, it kind of starts making sense once you actually do the long-winded way, but anyway, here we go. So what I'm going to do, the first step is I'm going to write a as an odd number. Now if you want to write anything as an odd number, you can write it as 2n plus 1. Even number would just be 2n. Now it says a and b are two consecutive odd numbers, all right, which means if a is 2n plus 1, b has to be 2n plus 1, and because it's consecutive, we add another 2 to it, because remember, if you get like 3 as an odd number, the next odd number would be 5, so it's 3 plus 2 is 5, and so on. So I can write this b as 2n plus 3. Okay, so that's my first step. My second step is actually trying to figure out what c is, but in terms of, I know it's asking for value of c in terms of a. We're going to do it slightly different and try and prove the question that you're always going to have a numerator as even and denominator as odd. So what does this mean? So we've got c is equal to b over a minus a over b. Okay, so because b is equal to 2n plus 3, and then a equals 2n plus 1, minus 2n plus 1 over 2n plus 3. Now, at this point, because it's one ugly looking equation there, we've got to cross multiply to actually have it all under one common denominator. Now, if you are not comfortable with cross multiplication, think about it like this. So hang on, let me just give me some space here. So I got 2n plus 3 over 2n plus 1 minus 2n plus 1 over 2n plus 3. Basically, if I want the denominators to be the same, I need to multiply the right-hand side fraction with 2n plus 1 in the denominator and 2n plus 1 in the numerator. And as for the left-hand side fraction, I'm going to multiply by 2n plus 3 and 2n plus 3. Okay, so what I end up having is c is actually equal to 2n plus 3 squared minus 2n plus 1 squared, and the whole thing is divided by 2n plus 1 and 2n plus 3. Okay, so the next part is I need to actually expand the brackets at the top. So I'm going to get 2n plus 3 multiplied by 2n plus 3 minus 2n plus 1 times 2n plus 1. And the denominator, I need to expand the brackets, which means I'm going to get 4n squared plus 6n plus 2n plus 3. Okay. Now the numerators, I got to expand the brackets. Now I'm just going to skip one line here, guys, because I'm just running out of space here. So 2n plus 3 squared, actually, I can actually do it here. 2n plus 3 times 2n plus 3 is going to be 4n squared plus 6n plus 6n plus 9. So I'm going to get 4n squared plus 12n plus 9. Okay, so that's what I'm going to get here. 4n squared plus 12n plus 9. Now, and that's going to be subtracted by 2n plus 1 squared. So I've got 2n plus 1 times 2n plus 1, which is going to be 4n squared plus 2n plus 2n plus 1. So I got 4n squared plus 4n plus 1. So that's going to be in that bracket, remember that. 4n squared plus 4n plus 1. Now also have a look at the denominator. I can simplify that to be 4n squared plus 8n plus 3. And in the next line, I need to get rid of that get rid of the brackets. So I'm going to get minus 4n squared minus 4n minus 1. And the whole thing divided by 4n squared plus 8n plus 3. Now simplifying this, I can see that 4n squared and 4n squared disappear. And what I have is 8n, and I've got plus 8. And that's divided by 4n squared plus 8n plus 3. Okay, so this is the proof part right here. All right, but what's important to notice is that you actually have to say it out loud. But not say it out loud, but like actually in the paper. See, you've got 8n plus 8. I'm actually looking for space now. So 8n plus 8 will always be even. Because whenever you take a number and you multiply it by an even number and you add it with an even number, it'll always be even. And you actually need to write this out, guys. Okay, you can't just kind of like just say it's even. And then the bottom number, the denominator, will always be odd. The reason it's odd is because if you take 4n squared, that's going to be an even number, because whatever number n is, if you multiply it by 4, you're going to get an even number. And the same applies for the 8, because whatever number you take as n and you multiply it by 8, it's going to be even number. So you got an even number plus an odd number is always going to be odd. So that means you can actually say 4n squared plus 8n plus 3 is always odd. Okay, as I said, I know I actually just verbally explained it, but you guys need to actually kind of write that as a statement there. All right, and that gets you an excellence. In terms of achieved and merits, it's one of those weird questions where you have like multiple bullet points that you can get achieved for. For example, you could get achieved if you had got the denominator right. You could have got achieved for this skill right here, for putting them into a same denominator. So yeah, it's just quite a few kind of ideas. You could also get achieved for that part there, writing it as 2 consecutive odd numbers. So yeah, wide range of things that you can actually get achieved for. But for merit, you actually need 3 of these achieved skills. Yeah, it's a weird paper. Don't ask me. So yeah, guys, that's basically it. If you have any questions or comments, just pop it in the comment section below. But as usual, thank you for watching, and good luck for your exams. And as usual, don't forget to like, share, and subscribe this video.